GCSE question of the week, week 6, foundation and higher first. We have a rectangle. We have some sides labelled. It looks like we have 2x plus 3 centimetres and we have x minus 5 centimetres. So we've got some algebra to do. Okay, let's have a look at the question. The perimeter of this rectangle is 44 centimetres. Find the value of x. Okay, so the first thing we need to notice is we've got perimeter. What's the perimeter? The perimeter is the lengths of all the sides added together. Okay, so a really common mistake here would be to multiply those two brackets, 2x plus 3 and the x minus 5. That would be wrong. That's going to give me the area. Okay, so we need to find the perimeter. So let's write an expression for the perimeter of this rectangle. Well, obviously, we know that if the top length is 2x plus 3, we know the bottom length is 2x plus 3. And if we know the right-hand side is x minus 5, then we know the left-hand side is x minus 5. So two ways we can do the next bit. We could say we've got 2x plus 3, although in this case we don't really need the brackets too much, let's put them in, plus 2x plus 3, that's the one at the bottom, plus an x minus 5, plus an x minus 5. Right, so we now could add up those x's. We've got 2x plus 2x plus x plus x plus 6x. And we've got plus 3, positive 3 and negative 5 and negative 5. Okay, well that's 3 plus 3 gives me 6. Subtract 5 will give me 1. Subtract another 5 will give me negative 4. Okay, or if you like, we've got positive 6, negative 10. Okay, we've got 6 subtract 10 will still give me negative 4. So this is our expression for the perimeter of the rectangle. Okay, now another way to get that would have been, we could have said we've got 2 times 2x plus 3 plus 2 lots of 2 times x minus 5. And we could expand, we could multiply out those brackets. It's going to give us 4x plus 6 plus 2x. Now here we need to be a bit careful. We've got positive 2 multiplied by negative 5. That's going to give me a minus 10. And we get the same thing. We simplify that. We've got 4x plus 2x. It's going to give me 6x. Positive x, negative 10, it's going to give me 6x minus 4. So either way, we've got the same expression. So that's our perimeter expression. Let's get the red back. Okay, so 6x minus 4 is our expression for the perimeter. Well, in the question it tells us that that perimeter has got to equal 44 centimetres. So we can now go ahead and write 6x minus 4, that's our expression for the perimeter, equals 44. And now we've got an equation, a linear equation that we can solve. Okay, so let's go on and solve that equation. Go away. Let's go ahead and solve that equation. Okay, so what do we want to do first? Well, if I add 4 to both sides, it's going to get rid of our negative 4 on the left. So we've got 6x equals 48, and if we then divide both sides by 6, 6x divided by 6 is just x, and we need to divide this side by 6. 48 divided by 6, that's going to be 8. Okay, so x is 8 centimetres. Okay, let's have a look at the higher tier question. Okay, so it looks similar, but this time we've got 2 rectangles. And crucial different keyword this time is we have area. So these 2 rectangles have the same area. So we're going to go ahead and write some expressions, one for each rectangle, but this time we do want to multiply the length of the sides, because this time we're dealing with area. What's the area? Is the space inside that shape. Okay, so we're going to find the area, an expression for the area of the first rectangle. Let's call this rectangle 1. Okay, so rectangle 1, let's go. So we know the area of rectangle is length times width, or height times width, whatever you want to call it. We've got x plus 6 and multiplied by x minus 3. Okay, what are we thinking? We're thinking FOIL it. Our two brackets need multiplying. Let's go for FOIL. Okay, so we've got first terms, x squared. We've got outers, x multiplied by negative 3. It's going to give me negative 3x. We've got inners. It's going to give me positive 6x. And we've got lasts. Two last terms, that's positive x multiplied by negative 3. That's going to give me negative 18. Okay, so we can simplify that. That's going to give us x squared minus 3x plus 6x. I make that plus 3x minus 18. So this is our expression for the area of rectangle 1. Now let's do rectangle 2. Rectangle 2 is a bit easier. Okay, rectangle 2, what are we going to do? We'll call this rectangle 2. Again, we want the area, so we're going to multiply the 9 by the x plus 1. Length times the width. Height times the width, whatever you want to call it. Okay, so easy this time. We're going to do 9 times x, we're going to do 9 times 1. That's going to give me 9x plus 9. Okay, so that's our second expression. That's the area of rectangle 2. And the two rectangles have the same area. So this time we can equate those two. We can write an equation that says x squared, let's get a new colour. We can write an equation that says, why is it giving me no pen? Why am I talking to myself? Right, we're going to write an equation that says x squared plus 3x minus 18 equals 9x plus 9. Okay, so here we're just saying that the area of the two triangles are the same. The area of the first triangle, that expression, is the same as the expression for our area of the second triangle. Okay, giving us an equation. Okay, blank. Right, let's simplify this. This is looking like we've got a quadratic on the left. Because we've got some terms of x squared. Let's simplify our x terms. So x squared. Right, we could do with getting that 9x on the right onto the left-hand side. So let's subtract 9x from both sides. That's going to give me positive 3x subtract negative x. Sorry, positive 3x subtract negative 9x. That's going to give me minus 6x. And we've still got the minus 18. We've now got just the 9 on the right hand side. So let's subtract the 9. What does that give us? That gives us x squared minus 6x. Then we've got negative 18 subtract 9. Okay, that's going to give me minus 27. And 0 on the right. Okay, now as soon as we've got a quadratic to solve like this, if we can get 0 on the right, we're looking for the root of the equation. We know we can solve the equation. Okay, to find the x values that would give us 0. As usual, we've got several ways that we could solve this quadratic equation. We could use the formula, we could complete the square. Okay, it looks to me like we've got numbers here that we're going to be able to factorise. That's going to be the simplest thing to do. Okay, so let's try and factorise this equation. So we have x squared minus 6x minus 27 equals 0. So we're going to factorise. We're going to put x plus or minus something, and we're going to put plus x plus or minus something equals 0. And what are we looking for? Well, we're looking for two numbers that multiply to give negative 27. That product is negative 27, and the two numbers need to give us a sum of minus 6. My pen button's not working, it's annoying me. Okay, so what am I thinking? Right, well, we could use 1 and 27. We could use 3 and 9. Now, as soon as I put the 3 and 9, that looks good to me, because I think I can get a 6 out of those. Alright, we know we've got to have negative 27. That means I've got to have a plus and a minus. Positive times negative is going to give me a negative. Okay, if I put my 3 and my 9 in, well, I can notice I've got negative 6x here. So if I can make the minus term the bigger number, put my 9 there, and my 3 there, that looks good to me, because when we expand, okay, we'll get x squared plus 3x minus 9x. That does give me negative 6x. And then the positive 3 times the negative 9 will give me minus 27. Okay, so we're factorised. So now we've got an equation that says x plus 3 in brackets multiplied by x and minus 9 in brackets equals 0. So what is the x? Well, hopefully you can see that the solutions of this equation have to be x equals negative 3 and x equals positive 9. Now they're the solutions to that quadratic equation, but we're dealing with a real life rectangles here. Okay, and we know that x is going to be one of those values. But if I try to put x is negative 3 into this expression for the length here, we'd get negative 3 subtract 3, which obviously gives us negative 6. Now, a negative 6 centimetre length makes no sense whatsoever. Okay, so we can discount this value. It's a solution to the equation, but it can't be an answer for this real life problem. So x has to be 9. So we're done. X equals 9. Doesn't need to be centimetres this time because x is just the value. Okay, we'll get the centimetres out from our units at the top here. So find the value of x. It's 9. Well done. Before I upload, in the first question, at the end, we didn't need centimetres, we just needed x equals 8. In the second question, when I start writing in green, you may have thought, why is he yabbering on about triangles? These are not triangles. And you'd be right, they were rectangles. We all know they're rectangles. I then start talking about subtracting negative x. Subtracting negative 9x maybe. I just meant subtracting 9x. But I am very, very tired, and I am very stupid. So please forgive those slight errors. The calculations are all good. Enjoy!